what I've got here is a surface in gray, which is described by this f of xy here. And then I have two vectors on it. I have a red vector here, the smaller one, in this view, and then the green one. The red one is a unit vector that starts at the same point P as the gradient vector here. All right. So what the directional derivative does is, that's what we're talking about, is it tells you the slope of the curve in the direction of u. And you use the gradient to get there. So in previous videos we showed that the gradient was the vector, the horizontal vector, these 3 dimensions, the horizontal vector which points in the compass direction of steepest ascent. So if you're on the curve itself, if you're on the graph, the surface itself, excuse me, then apparently we have to go northeast to get on the surface for the slope of steepest ascent. So what if I want to move in the direction of like this red vector here? Well, that'll give us, that's the directional derivative. So what I've done is I've created, I've done all the same work that I've done in previous videos for the gradient, but now here's this H point that I'm using as a point. It's going to be what I'm going to be using for my, to help me make my unit vector. So notice that I have my unit vector u, which is p comma p plus h. P is the point on the graph, and then I add p plus h to get the unit vector. And so if you look, let's look at it from above. As t goes from 0 to 2 pi, the unit vector goes around with it. Okay, so that's the unit vector is the vector I need to find the slope in that direction. All right. If you're not given a unit vector, you have to make it a unit vector for the directional derivative to be correct. So anyway, so I got my gradient vector here in green. Let me take off the surface for a second, and you'll see it. And what I've done is, as we go from 0 to 2 pi, and as t theta basically goes from 0 to 2 pi, the vector goes around circle. Now this blue dot gives us the actual value of the directional derivative. All right, and what I've done is I've made it so that the directional derivative value, the actual value of the directional derivative, is these numbers on the x-axis. And so what I did was I said g dot u, which is the gradient vector dotted with u, and then I let L be d comma 0, so that it just goes along the x-axis as t changes. All right, and then if you look, let's go ahead and get the surface back on here. If you look, the point can change as well according to what A and B are. All right, so you can go up and down, things like that. So I'll make a second video to finish this.